Hello and welcome to the walkthrough for my 16th Secure Code Viewer Challenge, which is a file upload vulnerability that we will be able to escalate to remote code execution. As always, let's start by having a look at the code. But before we do that, I want to just fire up that challenge, which we can do via Docker Compose up, which takes a moment. So I just want this to run while we start looking at the code. So there are two main files here. There is the file upload servlet Java, and then there's an index HTML file. Let's start with the file upload servlet. So we got a couple of imports, and then we have the upload route, which is the main route of this challenge. And in there we have a post endpoint. And let's see what this is doing. So it gets the file from the request, and you may have heard me say this already. Whenever I see something like this, request.I all ears, like I pay a lot of attention to this. So we make a mental note of this. This comes directly from the request. This is attacker controlled, meaning this variable here, file path, is also attacker controlled. Then we get the file name. Okay, we store another variable, again, attacker controlled. We check if the file name ends with .jsp, which is a Java template file, right? And if so, we just send back an error. We just basically tell the user, no JSP files allowed here. And this is just to prevent you from uploading a web shell. So we want to make sure that you just that you can just go ahead and upload a JSP, right? That allows you to get remote code execution. And just for you to have a little bit of an idea how this very common Java JSP attack vector would look like, let's check out that web shell here. So that's a very, very simple web shell. You see something similar in Java, PHP. You can do it in any language, right? And this just takes the CMD parameter, the command parameter from the request, and then runs it here, right? And we also make sure that we provide a little bit of information about the response of the command to the user, right? So that they can see what the command actually does. But ultimately, we just take a command from the request and then run it and provide some output. That's what I mean by a very simple web shell. All right, let's go back to our file upload servlet. And afterwards, we make sure that the uploads folder, which is the location where we want to store the uploaded files to, we make sure that this folder actually exists. And then below that, we got a bunch of Java stuff, classic Java stuff. We got input streams, output streams. But what that's basically doing is we take that file that we got from the request. Remember, file path was up here, was the file from the request. We get that input stream, meaning that actual file, and we store it into an output stream, and we create a buffer. Like, I mean, that's just really, if you're a Java dev, you've seen this all the time. This is just Java language for, we take that file from the request and we store it in the upload directory. That's what's happening here. And last but not least, if everything worked out, we just print a little message to the user that the file upload worked, and we tell them what kind of file they uploaded, like just give them the name and then a go back button. Now, if you're looking at this line, you might be thinking, file name, wasn't that attacker controlled? And if we go back, we see, yeah, that's the actual file name of the file that the user or the attacker uploaded. And this is rendered with an HTML, with a content type of text HTML. So this looks like it could be a cross-site scripting, right? And in retrospective, I probably shouldn't have put that in there. So it's probably not reasonably exploitable. I mean, it would depend on how the real app is set up. But here in our concrete scenario, since this is a post request, it would only be exploitable as self-XXS. So the only scenario where a post request can be exploited for cross-site scripting is for stored XXS, meaning for a cross-site scripting vulnerability where the file name here would actually be stored, and then maybe someone else can see a list of all your files with their names, and then that could potentially be exploited. But here, that concrete scenario, It's probably not exploitable in a reasonable way, but yeah, it's a bit of an abstraction, so I put it in here. Yeah, so if you saw that, that's really good, but probably not exploitable. But let's move on. Okay, and let's look at the index HTML file, which is as simple as it can get. Just a little form that allows us to upload a file. Okay, so let's take a look at the running app. So this is our index HTML file. And let's see if we upload a web shell, JSP. Then we get the error JSP files are not allowed, which is exactly what we were talking about earlier. Remember, if we go back to the code, remember this part here. This is why we're seeing this error. So let's go back in here. But the problem is, and that's one of the most common issues with block lists, that there are other ways to upload web shells in Java than just JSP files, right? And this is ultimately how we will be able to exploit this. And one of the alternatives to JSP is a JSPX file. So let's go back to VS Code. And if we take a look at that JSPX file, it's a little bit more complex than a JSP, but ultimately it's the exact same. It's just a little web shell, takes a command from the request, then executes it, and then prints the output of the command back to the user or back to the attacker. So that's all we're doing here. So let's change this a little bit so that we can get both the code and the running app side by side. And if we now try to upload that JSPX file, we will see that it works because only JSP files are allowed. And now what we want to do is we want to interact with that file, right? But for that, we need to know how to access it, right? So let's go back to the code. And if you remember here, the uploads folder is created and the file is stored within the uploads folder. So that means we should be able to find it like this. And we don't see anything, right? But that's expected because if you remember, the file doesn't really do anything, that web shell, right? By itself. So we need to provide that command. And we can see here, it's working, right? Because if you remember here, we take the CMD parameter, and in our example now, who am I? We execute it, and we provide back the output, which in this example, I'm in a Docker container, and I'm root, right? So this is working perfectly. And that means we have successfully achieved remote code execution. So we totally own that server now. So before we talk about remediation, I would like to take a quick moment to talk about the LeadRace community. So since you're clearly interested in secure code review, otherwise you wouldn't be watching this right now, you will love the LeadRace community. And this is what it looks like. So this is a community, I just started it last month in September. And this is a place where I host all my secure code review challenges in one central location. So you can see they're all in there. There will also be community challenges. There's one that's going to be there pretty soon. And I envision this to be a forum for a lot of other creators to create their own challenges. And on top of this, you can discuss challenges in this channel here. There's gonna be a lot more. So I haven't fully figured it out yet, besides the secure code review part of it. But I want this to be a forum where people just go in, talk secure code review, talk application security, or anything security related. And everything's free. There may be paid courses later on, but the community itself will always be free. So yeah, if you haven't already, please consider signing up. Thank you. And now let's jump into the remediation. Okay, let's get rid of this and let's make this a bit bigger, and then we can talk about remediation. All right, so file uploads are really not that easy to get them right. And there's a lot of things you need to do, not just in the code itself. And a fantastic resource is the Overs file upload cheat sheet. So this cheat sheet tells you exactly what you should do, what you may want to do. And yeah, it's just a really great resources because again, it's very, very difficult. But I want to show you in the code, if we go back to Visual Studio Code, I just want to tell you some really basic things here. So I'm not gonna implement all of this because it doesn't really make sense considering again there's a lot of things you should be doing outside of the code. For example, every file should be run against the virus scanner, right? You want to make sure that people don't upload viruses. But there's certainly some easy code level wins that we can achieve. And the first thing I'm looking at is that part here where we check if the uploaded file name ends with .jsp, and if so, we reject it. And that's obviously a very basic block list, and block lists historically have been proven to be bypassed a lot of the times. It's just not a good idea from a security point of view. And what we want to do instead is think about what kind of files we want users to upload. Say, for example, this was a profile picture. Then we could, instead of blocking .jsp, only allow file names that end in, say, .png or .jpeg or something like that. And that would be significantly more secure already. Just doing that little change where you make sure that only image files can be uploaded. On top of this, another thing that's going really wrong here is that part here, which is where we store the uploaded file in the uploads folder in the web root. So if you remember the code here, the reason we can pawn this is because we can access our uploaded file via the uploads folder, right? And we really don't want this. So instead, what you should be doing is uploading the file, like storing it somewhere out of the web root. So instead of, say, it's an Apache, instead of storing it into var, whatever, you can store it, say, in the user's home directory, any location that can be accessed from the server, any location not on the web root would work just fine. So that would be another big thing. Never store uploaded files in the web root unless you have to. And then another thing I'm missing here is input validation. So the file name, of course, we just talked about the allow list, which of course is input validation, right? But we may also want to check if the file name is, for example, alphanumeric and has only, say, certain allowed special characters, maybe underscores, maybe, I don't know, it's just something to think about, but you probably don't want to allow all special characters for file name here, right? So you could implement a regex check to make sure it's only alphanumeric. That's always my favorite one, because that you can't really pawn anything with alphanumeric characters with numbers and letters. Like, I mean, maybe you can, but not here. So yeah, that would be some really quick wins, like 3 easy code level changes that would make this impossible to exploit and would make the whole file upload significantly more secure. And just to add, when I say alphanumeric, what I mean is you split the file name into 2 parts, the actual name and the extension. So you take the extension and then you validate it against the allow list, say it must be .jpeg or .png or whatever, and then you take the left part, which is the actual file name, say if it's test.jpg, then you take the test and you validate this to be alphanumeric. Just to make sure we understand each other, because obviously if you want to have an extension, you can't validate the whole file name to be alphanumeric, right? Yeah, I guess that's all I got for today. So same as every time, thanks so much for watching. If you have any feedback for me, please feel free to let me know. Put a comment on the YouTube video or shoot me a message on LinkedIn. And if you want to support my work, then please consider subscribing to my YouTube channel and join the LeoTrace community. Thanks so much. Bye bye.